Saxon Advanced Algebra, Lesson 91. Greetings, my students. Hope you are having a lovely day today. For me, it is Tuesday afternoon. The sun is shining, the plants are growing, and it feels like spring is just creeping into the neighborhood, which is very exciting to me. This lesson is also quite exciting because I think you'll find it easy to wrap your brain cells around, and it will feel relaxing after that last marathon we did with the double angle and half angle identities, which was a workout, I'll be the first to admit. I'm going to begin by refreshing your memory about what we did before. Those are called arithmetic progressions. And in those, we started with what we called an initial value. And then we had what we called a common difference. And we would take that initial value and we added the common difference to it. And we would number these terms. This was the common difference. Okay, so that's how we would derive the first two terms. For the first term, we would take just the initial value. Then for the second term, we would add the common difference. And it can be a negative number, but in this kind of progression, it's always adding or subtracting, if you want to think of it that way. As I've been explaining to the Algebra 1 halfers, adding a negative number and subtracting are the same thing. So in algebra, it gets kind of muddied. Subtraction isn't really a thing, but then it kind of is. Okay, so we add the common difference. For the third term, we take the initial value and we add 2 times the common difference. Basically 2 common differences, right? And we notice that there's this relationship. The coefficient in front of the number of common differences is 1 less than the number of the term. So we can kind of ... sequence this and then come up with a generalized expression. For any term, you take A1 and you multiply the common difference times the number that is 1 less than the number of terms, right? 2 is 1 less than 3. The invisible 1 is 1 less than 2. And technically, it's 0 here, right? And 0 is 1 less than 1. Oh, it kind of works. So this is like a globalized formula that we can use when John wants us to find, the 54th term of something. We don't have to calculate them all the way along. We can just use this for any term and come up with the value, okay? That's what we did before. Notice it involved adding or subtracting. With geometric progressions, we're going to do the very same thing, only it'll be multiplying. Flip the beautiful notebook over. So here's the way the progression looks for geometric. The first one is A1, just like before. We call it the initial value, just like before. All right, and then we multiply for the second term, A1. This time, instead of calling it the common difference, we call it the R, we call it the common ratio. Ratio is a word that most students, they feel the ground move under their feet. They're not quite sure what a ratio is, what does it mean. Don't overthink it in this application. A ratio is often a fraction. The more important thing is that we're multiplying. That's what I want you to focus on, is that the R tells us that we're multiplying. Okay, and then we have the same situation where for the third term, for example, it's the initial value times the common ratio times the common ratio, right? We multiply twice. And this time, rather than express that in a coefficient, we express it as an exponent, right? Because we're multiplying twice. Okay, I'll do a fourth one. A1 times r to the third, right? And then we can take this all the way out, just like we did before, and globalize it. If you want the nth term, you take the initial value and you multiply it times r raised to the n minus 1 power. Okay? That's not so bad, right? It makes logical sense. It fits with what we did before. Oh, I love when it is fun. It doesn't hurt the brain too much. 91.1, find the fifth term in a geometric sequence. Ding, ding, ding. That means multiply. Geometric, as soon as I hear that, my brain dings. Whose first term is minus 2. A1 equals minus 2. And whose common ratio is minus 3. Now, we can do this. We're all set up. We just have to use this, right, to figure it out. That's no big deal. But before I go on, I want to say something that we will see. No, never mind. Let's just do it, and then I'll show you. No, it won't work out. Never mind. Sorry. So the fifth term will be a to the 1 minus 2. Put brackets around it, or buckets, so that we don't freak out over our parentheses. And then we raise minus 3 to the power of 5 minus 1. So that's to the fourth power. Okay, beautiful. That makes perfect sense. So now let's raise 3 to the fourth power. 3 times 3 is 9. 9 times 9 is 81. So this is 81. It's going to be positive, right? Because it's an even number. So that there'll be 4 of them. They'll turn into 2 pluses. So I'm just working this way in my multiplication. Minus 2 times positive 81. And then that simplifies to negative 162. Final answer. That is the value of the fifth term. And that's right. Yay. Oh, the first one. Gosh, I wish they could all be so easy, right? No, it wouldn't be any fun if they were that easy, you guys. All right. Next one. Find 3 geometric means between 4 and 64. Now, we remember that geometric means are just the middle parts of any sequence, right? So we know we're calling this one the first, and then we need to find 3. So that'll be 2, 3, and 4. So that tells us that this is the fifth, all right? John did not tell us that this is the first and this is the fifth, but we can easily figure that out, right? Because he said find it, the 3 geometric means between 4 and 64. So we just set up the 3 in the middle and put those guys on the end, right? Okay, now what we're gonna do is we're gonna have to use this information to solve for A1 and R, right? We need A1 and R. Okay, well we have right here A1 equals 4. So that gets us most of the way there. And we know that A to the fifth equals A1 times R to the fourth, right? That's our formula. Where is it? There. That's our formula at work. And then we know that this value is 64. So from there we can say, okay, 64 equals A1 times R to the fourth. And then we also know that A1 is 4. So we can say that 64 equals 4 times R to the fourth. See how I was just filling in the blanks there? First I plugged this value in, then I plugged that value in. I could have done it all in one thing, but I was just going one thing at a time to help you see. You could jump all the way from here to there. That would be fine. Okay, so now what we need to do is finish solving this so that we can find out what R is. Divide both sides by 4. That is, I'll go back to the beginning over here. 16 equals R to the fourth, and then we take the fourth root, and we find out that r is equal to, here's where it gets slightly tricky. It could be positive or negative 2, right? Both of those would come out to a positive 16. So we have to consider two sequences for this. The first one is if r equals positive 2, and the second one is if r equals negative 2. Okay, and we're finding the 3, right? So let's turn our grid sideways so that we can make kind of like a chart. So the second term will be a1 times r, which is 4 times positive 2, right, in the first example, and that's 8. And in this one, it's 4 times negative 2, which is negative 8. Okay, that's our second term in two different sequences because we have two possibilities. Let's find the third term. This would be a1 times r squared. In this one, that would be 4 times 2 squared. 2 squared is 4. 4 times 4 is 16. Here, it would be 4 times minus 2 squared. Well, when we square this, it becomes positive 4, so we get positive 16. Huh, interesting. The first two were different by the sign. The second two are the same. Let's do the next term. This is a1 times r to the third power. So it's 4 times 2 to the third. 2 to the third power is 8. 8 times 4 is 32. Slide up a little bit so I'm more in the middle. Over here we have 4 times minus 2 to the third power. Minus 2 to the third power is going to be negative 8, right? 3 times, so we end up with a negative. And so that becomes negative 32. Oh, interesting, right? So the way John likes to see the answer is for this one, our sequence would be 4. That was our original number. Then 8, 16, 32, 64. And what John does is in the answers is he shows them all and then he underlines the means that we were finding. Remember the arithmetic means and the geometric means simply mean the middle numbers of a sequence. And that's what we were finding here, the 3 means. It doesn't mean the word mean as we've studied it before, which is like an average. I mean, it kind of is, but it has a different context when we use it with these progressions. Okay, so don't let that word trip you up too much. But look at what's happening with our progression over here. We start with 4. We go to negative 8, then positive 16, then negative 32, then positive 64. And these were the ones John set us out to find. And this shows you the point that I was stumbling around trying to decide if I wanted to make earlier, but I wanted to wait until we had a problem. One weird thing about geometric means is that the sequences don't always follow in an orderly progression on the number line. This one is jumping around, isn't it? Positive 4, negative 8, positive 16, negative 32. It's zigzagging back and forth across the 0 in the number line, which is common for geometric progressions that have a common ratio that is negative. Okay, that's what made that happen, is that negative sign in the common ratio. If you have a positive difference, you might still have negative numbers, but they will all be the same. With a negative common ratio, you're going to bounce back and forth because on odd numbered roots, you'll have a negative, and on even numbered roots, you'll have a positive. So this is quite common to get a weird, wacky thing like that, which you would never get in an arithmetic progression. If you have a negative common difference, you just are going backwards down the number line. If you have a positive common difference, you're working upwards. I hope that makes sense. Okay, so this is normal. Don't let that freak you out. Okay, 2 more problems. Example 91 Point 3. Find two geometric means between 2 and 1/4. Because we need to find 2. So this is the first one. And we have the second and the third. And then this is the fourth. Okay, we're going to do this exactly the way we did the last problem, right? It's the same idea. The difference is that we have a fraction. I wonder how that's going to change things. All right, we know that a to the 1 equals 2. That's cool. And we know that a to the 4th equals 1/4. And we know that that equals a to the 1 times r to the 3rd power, right? Because it's the 4th term, so it's the 3rd power. And then we can rearrange all of this to say 1/4 equals 2, the initial value, times r to the 3rd power. All right. Then we just have to solve this to get our value for r. Okay, I'm going to chase this number away. I initially think let's divide, but I don't want to end up dividing by a fraction, so let's multiply by the reciprocal. Okay, then we get, coming back over here, r to the 3rd power, because that cancels, not the r, the 2 and the 1/2, equals 1/8, and then we take the cube root of both of those, and we find out that r equals 1/2. All right. We are in good shape. With a cube, we don't have to consider the negative roots, because if this was negative, we would get negative 1/8 here. Since this 1/8 was positive, we only have one option, and that is positive 1/2. Does that make sense? If this was an even numbered root, then we would have to consider positive and negative. But in this case, it's got to be positive 1/2 because this is positive 1/8. Okay, so now we're ready to do our calculations. I'll do them up here since we don't have that. Last time it was too crowded because we had two choices for r. So it didn't really work to put them back up here. I had to make that chart down here, but now we can go back up. Okay, so this one is going to be 2 times 1/2, which is 1. And this is going to be 2 times 1/2 times 1/2. I'm going to do it this way. And that will be 2/4, which equals 1/2. So now I have all the information I need to write my sequence. It is 2, 1, 1/2, 1/4. And these are the ones that are the means John asked us to find. Beautiful, right? Okay, one more. Find 3 geometric means between -16 and -1. Find 3. So that means this is the first. Then we need to find 2, 3, and 4. And then this one is 5. Okay, we follow our same pattern. We know that a1 equals -16. And we know that a to the 5 equals a to the 1 times r to the 4th power, right? 4 is 1 less than 5. And then we can substitute in here. We say that -1 equals -16 times r to the 4th. Okay. Divide both sides by -16. And we get r to the 4th power equals 1/16. Okay, take the 4th root of both. We know that the 4th root of 16 is 2, but now we're back to the situation where r is equal to either positive or negative 1/2, right? Because if r was equal to positive 1/2, we would end up with positive 1/16 as its 4th to the 4th power. But if we had negative 1/2 to the 4th power, those the 4 minuses would end up positive, so we would get this as well. So again, we're in the scenario where we have to consider both roots. And so if we want to globalize a rule, you guys, we can do this. If the root that we're taking is an even numbered root, then we're going to have 2 values to consider. If it's an odd numbered root, then we just have 1. Okay? So that's something to keep in mind. Now we're ready to do our calculations, right? And we're going to have to do 2 of them again. This will be r equals positive 1/2 and r equals negative 1/2. We'll calculate the second term right here. That will be a to the 1. I'll write it down. A to the 1 times r. So that will be minus 16 times positive 1/2, which equals negative 8. And here it will be negative 16 times negative 1/2, which will be positive 8. Interesting, right? The positive common ratio gave us a negative value, and the negative common ratio gave us a positive value. That makes sense because our initial value is negative. So you see all kinds of interesting patterns crop up in these, and that's I think is part of what makes them fun. Okay, the third term, that would be a1 times r squared. So that'll be minus 16 times, I'll do it in my head, it'll be 1/2 squared, right? So that'll be 1/4, and that would be negative 4. Here, it's minus 16 times, okay, I'm going to square, right, because we're squaring this. That'll be positive 1/4. So look, we get the same number. And this happened last time too, right? When you square them, then the minus sign basically goes away. Okay, and now the fourth term, that's a1 times r to the 3rd power. So it's minus 16 times 1/2 times 1/2 times 1/2, that's 1/8. And that gives us negative 2. And this is minus 16. Okay, it's the 3rd power, so this is going to be negative 1/8. And that simplifies to positive 2. Isn't that interesting? Weird things happening. Okay, so I'm going to summarize. I'll summarize our answers right here. I'll draw a box, because they won't really fit into the chart very well. So the first sequence is minus 16, minus 8, minus 4, minus 2, minus 1. These are the 3 means we inserted, right? Minus 8, minus 4, minus 2. And then the other sequence is minus 16, positive 8, minus 4, positive 2, negative 1. And those are the 3 we inserted. Okay? That's it. That is lesson 91. Now, we got a taste of this when we did the arithmetic progressions. Where we're going to go with these is we're going to start applying them in situations where we have letters instead of numbers and where we have binomials instead of just single values. The math gets a little wonkier, but these same basic patterns and formulas like we have here. There's the one for the geometric progressions that we were just using, and then this one for the arithmetic progressions. We'll still use these. When it gets harder, it'll just be, the math will be a little crazier because we'll have wonkier things to multiply and take roots of. Okay, so make sure you have these 2 bits in your notes and make sure you understand how to use them. It's pretty straightforward, and John is giving us some nice baby steps here with these problems where the numbers stay safe and solid. All right, that's the end of 91. Thank you. Goodbye.